Welcome to Lecture 12, 3.3, Measures of Central Tendency and Dispersion from Grouped Data. Okay, so by definition, class midpoint is the sum of the consecutive lower class limits divided by 2. Alright, let's take a look at the approximate mean of a variable from a frequency distribution. So for the population mean, we have mu equal to the sum of xi, fi, all over the sum of f sub I, which is going to be equal to x sub 1 times f sub 1 plus x sub 2, f sub 2 plus, and so on, until you reach the last values divided by f1 plus f2 plus so on until you reach the last values again, where x sub I is midpoint, fi is frequency, and n is number of classes. Oh, and this is from page 141. Alright, and then the sample mean. We have x bar is going to be the sum of xi, f sub I, all over the sum of f sub I, which is going to be basically the same thing. Divided by f sub 1 plus f sub 2 plus so on until f sub n. Once again, we have these values, where x sub I is the midpoint, or it could be the value of the ith class. So keep that in mind, value of the ith class. Alright, let's take a look at an example problem. The frequency distribution in the table provided represents the 5-year rate of return of a random sample of 40 large blended mutual funds. Approximate the mean 5-year rate of return. Alright, so to do this, what we want to do is first determine the class midpoint of each class, and we'll do that by adding consecutive lower class items and dividing the result by 2. So, let's see that. 8 and 9. We'll add those together. Actually, let's go ahead and create a table for what we're doing here. Okay, so we have the 8 to 8.99. That's our first column. And for the first one, we're doing class midpoint. Actually, let me back up on this. Class midpoint. X sub I. to 8.99 and 9 to 9.99. So to find the class midpoint for this one value here, my first column, I'm going to take my 8 and my 9, which are the consecutive lower class limits, and then we'll divide that by 2 as per the definition. Divided by 2 is going to give us 8.5. And then let's go ahead and start filling this in for the rest of them. So we have 10, 9, 9, 11, 11.99, 12, 12.99, and so on. You can go ahead and pause the video and work this out by yourself. I'm going to do the same and write down the charts. Alright, so okay, hopefully you're able to write this chart down. So when we go ahead and do the divisions, so this would be 9 plus 10 divided by 2, 10 plus 11 divided by 2, 11 plus 12 divided by 2, and so on. I'll go ahead and pause the video and write these in. Alright, so I've written in all the items, and then I'm going to go ahead and do divisions and pause the video and write those in again. Alright, so once again, do the division, the addition, then the division, and the frequency. You're just going to copy down that frequency from the chart there, so that's 2, 2, 4. 1, 6, 13, 7, 3, 1, 0, 0, 1. And then we'll finally do the x sub I times the f sub I values. So that'll be 8.5 times 2, which is going to equal 17. Then 9.5 times 2, 10.5 times 4. Once again, I'll go ahead and pause the video and fill in these values. Go ahead, pause the video, and see if you can complete this chart by yourself. Alright, and then filling this out, when we do the multiplications, we'll get the following. $11.5, 75, 175.5, 101.5, 46.5, 16.5, 0, 0, and 19.5. Alright, and finally what we're going to go ahead and do by our formula, what we need is the sum of our x sub I. Oops, that was supposed to be the highlighter, not the eraser. Sum of our x sub I, fi, and sum of fi. So the sum, oops, wrong pen again. The sum of the following column right here of fi, adding up all of these values, you'll get 40. And then the sum of xi, fi. Let's go ahead and do that on the side. So we know that x bar is sum of, x sub I, f sub I, all over sum of f sub I. We know the sum of f sub I is 40. And then what are the sum of the x sub I, f sub I? 17 plus 42, plus 19, plus 42, plus 11.5, plus 75. Once again, I'm getting these from this chart here. Plus 175.5, plus 101.5, 46.5, 16.5, running out of room, plus 0, plus 0, plus 19.5. Oh, that's not a lot of room there, sorry. Okay. Adding those all up with a calculator, we'll get 524 divided by 40, which gives us 131. Sorry, 13.1. So x bar, or the sample mean, is 13.1. So let's compute the weighted mean. The weighted mean, denoted by x bar w, w for weighted, of a variable can be expressed with the following formula. And I didn't leave that much room here, so hopefully I'll change that in your notes. But I'll put it right here. X bar w is the sum of your wi times x sub I divided by sum of wi. Okay, so let's take a look at this. Example 2. Marisa just completed her first semester in college. She earned an A in her 4-hour statistics course, a B in her 3-hour sociology course, an A in her 3-hour psychology course, a C in her 5-hour computer programming course, and an A in her 1-hour drama course. Determine Marisa's grade point average. Alright, so what we're going to do is assign point values to each grade. We're going to let A equal, let an A equal 4 points, B is 3, C is 2, and a D is 1. We don't actually have a D, so we don't need that. And the number of credit hours for each course determines the weight for each course. So a 5-hour course gets a weight of 5, which is often how your grade point average is calculated. So her GPA is going to equal the weighted mean, which will be the sum of the wi, xi, all over the sum of w sub I, which is going to be, let's see, first thing she has is her 4-hour statistics course, which she got an A in. So it'll be 4 times 4, because she got an A, plus the next one, a B in a 3-hour sociology course. So it was 3 hours, and it was worth 3, plus an A in her 3-hour psychology course. So she had an A, which is worth 4, and it was 3 hours. Oops, wrong way around. And then 5-hour computer programming course. So 5 hours, and she got a grade of 2, because the C is 2. And lastly, she got an A in her 1-hour drama course. So 1 hour and the worth, all divided by the sum of the weight, WI. Oh, sorry, let me write that down here. Forgot that in the definition. WI is the weight, and XI, value of ith position. That is important in the formula. Sorry, I forgot to mention that earlier. So we're looking at the weight. So once again, we multiplied the weight by the value. Okay, so then let's go ahead and add up all the weighted values, which we have are 4, a 3, another 4, sorry, another 3, a 5, and a 1. And then let's see, what do we get? 16 plus 9 plus 12 plus 10 plus 4 divided by 5, 10, 16. Which we get 51 over 16, which, bringing this to the side, the GPA is 3.19. So you'd write a sentence saying Marissa's grade point average for her first semester is 3.19. Alright, so let's take a look at the approximate standard deviation of a variable from grouped data. So what are the formulas? For the population standard deviation, we have sigma equals square root of the sum of your x sub i's minus mu squared times f sub I divided by the sum of f sub I, where x sub I is the midpoint or value of the ith class, and f sub I is the frequency. Ew, that's not a nice frequency. Frequency of the ith class. So, for sample standard deviation, we use the small s equal to, pretty similar looking notation here, except we're using x bar for our mean, fi all over sum of f sub I minus 1. One of the biggest differences here between population would be our minus 1. Alright, let's go ahead and use the data in the table provided to approximate the standard deviation of the 5-year rate return. Okay, so previously we knew from this table that we had, from the data that we found before, we know that the sum of f sub I was 40. So now what we need to do is find the following. We need to note our x bar value. So let me go ahead and write out the chart we want. Oops. xi minus x bar. We're slowly filling in the values for the formula that we have. And then lastly in the formula, we have our x sub I minus x bar squared times fi. Last thing in the formula we use. Once again, I'm going to go ahead and label the side with all of these values. So I'll pause the video and then return. Alright, and so we found the sample mean previously in our other example. I believe it was example 1. So our sample standard deviation was 13.1, so I'll just go ahead and write that down for all of these. Alright, and then we need to do our x sub I minus x bar. So the x sub I minus x bar is going to be the class midpoint values we found previously from our other table. So actually I'm going to go ahead and write in the x sub I bar, just so we remember what that was. So the x sub I we had previously for all of these. Remember when we add the 8 and the 9 and divide by 2. Let me go ahead and fill out this chart. Basically as a pattern. Alright, then let's do the subtraction. So we have 8.5 minus 13.1. Then we'll do 9.5 minus 13.1. And so on. So I'll go ahead, pause the video, and work this out, and then you go ahead and check in with me in a second. Hopefully you'll work on this by yourself with the video paused. Okay, so let's go ahead and compute these. I'll go ahead and write these in blue since there's so many numbers going around. Negative 4.6, negative 3.6, negative 2.6, negative 1.6, negative 0.6, 0.4. Ooh, we're getting into positives now. 1.4. 2.4, 3.4, 5.4, oh, 4.4, sorry, that was supposed to be 4.4. 4.4, 5.4, and 6.4. All right, so we found that part. Next, we're going to add on to those. We'll square these values and then multiply them by the frequency. So I'll go ahead and set this up. So let's take these values and put them in the squaring section. Okay, so I filled that out, and then we're going to multiply by the frequencies. These are our frequencies. So we have by 2, by 2, by 4, 1, 6, 13. Oops, it looks like a weird symbol there. 13, 7, 3, 1, 0, 0, 1. And what do we get when we work these out? So we'll get a 42.32, 25.92, 27.04, and I'll go ahead and fill these. Okay, after working all that out, we get these values. And lastly, what we want is we want to have the sum. Well, okay, let's go ahead. Writing out our formula for the sample is the square root of the sum of x. Actually, let me write this out on this side. We need this formula, sum square root xi minus x bar, bar, squared f sub I divided by sum of f sub I minus 1. So we already know the sum of f sub I, which we found previously. That was 40. Now we need to find out the sum of those values. So let's do this on the side. The sum of x sub I minus x bar squared, f sub I. So this can be found by adding up all of these values here. So put that in your calculator. When we do that, we find out that this equals 185.6. Okay, so now we have sum of f sub I is 40, and the sum of this values, we can go ahead and plug that into our formula. Actually, let me write out this one on the side so my work's not too messy. Got to make sure everything's able to be read and the work is clear. So s equals the square root of, let's see, well that is this value right here, 185.6, divided by, and the sum we said was 40, and minus 1 as per the equation. So then S is going to equal the square root of 185.6 divided by 39, which when you plop into your calculator, could approximately be about 2.182. So, let's write our answer. The approximate standard deviation of the 5-year rate of return is 2.182%. And box our answer. Please email me if you have any questions with the homework.